Welcome to The Explainer. Today, we are diving straight into one of the most critical, maybe the most critical skill in aviation. What on earth do you do when the engine goes silent? It's all about turning what could be a catastrophe into a manageable problem, really just a problem of physics.
Okay, so picture this. You're a pilot, thousands of feet up in the air. That steady drone of the engine, that's your constant companion up there. And then, poof, it's just gone. That sudden, almost deafening silence, well, that's the sound of a very serious emergency getting started. So in that split second, your adrenaline is just surging, right? And the pilot's very first move, that's the one that changes everything. I'm talking before you even think about troubleshooting, before you even reach for the radio, one thing has to happen, and it has to happen right now.
And that one thing is fly the airplane. That's it. Your absolute first priority. This isn't some panicked move yanking back on the controls. No. It's a deliberate, really precise maneuver, all about managing the plane's energy, squeezing every last bit of potential out of every single foot of altitude you have left.
Okay, so let's really get into how this works. It's a pretty foundational concept. The moment your engine quits, your airplane, well, it's a glider now. And your only fuel, the only thing you've got left in the tank, is your altitude. You have to think of it like currency. You've got to spend it as efficiently as you possibly can to buy yourself distance over the ground.
And that brings us to the magic number. Best glide speed, or VG for short. This is the absolute sweet spot. It's the speed where your airplane is at its most efficient, just slicing through the air, turning that height you have into the most possible distance. See, if you go too fast, the air resistance on the plane itself, that's called parasite drag. It just slows you down. But if you go too slow, your wings have to work way harder just to keep you flying, and that creates a whole different kind of drag. VG, it's that just right speed, that perfect balance, right in the middle.
Now, a chart like this one for a Cessna really brings it home. Look at this, from 6,000 feet above the ground. And remember, that's over a mile straight up. If you can nail that perfect glide speed, you can travel about 9 nautical miles. 9! Just think about the huge circle of land that gives you to find a safe place to land. It's an incredible amount of options, but only if you manage that energy just right.
And this best glide speed, it isn't a guess. It's not something you feel out. It is a specific, hard number published by the manufacturer for every single aircraft. And if you look at a table like this, you'll notice something interesting. It usually falls right between Vx, that's your best angle of climb speed, and Vy, which is your best rate of climb speed. It's a number that every single pilot burns into their memory for the plane they're flying. Okay, but here's the thing. That single number, it isn't totally set in stone. The published number is for a plane at its maximum weight. So if you're flying lighter, your true best glide speed is actually a little bit slower. But that's a minor tweak. The real game changer, the one variable that can throw the whole textbook strategy out the window, is the wind.
And this is where we get to a really crucial insight, something that, standard training can sometimes gloss over. We're all taught to just pitch for that one book number. But glider pilots, the people who fly without an engine all the time, they know a secret, a really powerful one.
Yeah, this quote right here, it gets right to the heart of the matter. The idea that you should just always fly at the published VG, well, it's incomplete. And in some cases, it's flat out dangerously wrong. What works perfectly on a calm day can absolutely fail you when you're dealing with the real world.
And here's why. Let's say you're gliding at your perfect 65 knots, but you're flying straight into a 20-knot headwind, okay? So your airspeed indicator says 65, but your actual speed over the ground is only 45 knots. The wind is literally stealing almost a third of your range. That analogy of trying to run up a down escalator, that's exactly what's happening.
So here it is, the big, counterintuitive reveal. To get farther, to make it to that field in the distance, you don't pull the nose up to try and stretch the glide. You actually have to pitch the nose down and fly faster than the book says. I know, it feels completely backwards, but it is pure physics. Sure, you're descending a little faster, spending a bit more altitude each second, but you're covering so much more ground in that second that your total range actually gets longer.
And we're not talking about a small difference here. This isn't some minor adjustment. One study showed that just by flying 15 knots faster into a 30-knot headwind, you can increase your glide range by a whopping 20%. Think about that. That could easily be the difference between making it to the runway and not.
Okay, so we've kind of complicated things, right? We figured out that the best speed for covering distance isn't always the one printed in the manual. But now let's add another layer to this. What if your goal changes? What if it's not about covering the most ground, but about staying in the air for the longest possible time?
This really lays it out perfectly. A pilot basically has two different tools in their gliding toolkit. You've got best glide speed, VG, which is all about getting you the most distance. But then you have this other tool, a slower speed called minimum sink speed. And its job is simple: keep you descending as slowly as possible. You won't go as far, but you will stay airborne for the longest amount of time.
So how do you use this in the real world? Well, it's a two-step dance. Step 1, engine fails. You immediately pitch for your best glide speed to get yourself heading toward a safe landing spot, like an airport. Step 2, you make it. You're over the airport, and you've got altitude to spare. Now your mission is changed. You switch to that slower minimum sink speed. This allows you to just circle, buying yourself precious seconds, maybe even minutes, to check the wind, pick the perfect runway, and plan your whole landing.
So let's bring all this home. Real mastery in an engine-out situation isn't about just memorizing one number from a book. No way. It's about really, truly understanding how to manage your plane's energy. It's about knowing you have different tools and picking the right one for the right part of the problem.
So what's the bottom line here? It's all about having this dynamic mental toolkit. First things first, always fly the airplane. Then, you use best glide to solve your distance problem, getting to a safe spot. But if you have extra altitude when you get there, you switch tools. You use minimum sink to solve your time problem, giving you the moments you need to think and plan. That ability to adapt, to know which speed to use and when, that's the mark of a true pro.
You know, when you get right down to it, understanding all this stuff is what transforms the airplane from just a falling object into a really surprisingly capable glider. It gives the pilot choices, it gives them control, and it turns a moment of pure, raw panic into a calm series of calculated decisions that hopefully end in a safe, controlled landing.
And really, that's what this is all about. This isn't just a lesson for pilots. It's a perfect example of how having deep, nuanced knowledge can take what seems like an impossible crisis and break it down into a series of manageable choices. It's about knowing you always have more than one move to make,